Hello, I'm Li Hao. Today we're going to talk about a key each block. What is key each block? Well, it's like a each block but with key. But what does that key do? Well, we're going to learn about it in this video. Before that, let's take a look at one example. So over here, I've prepared an example which, again, we loop through a list of colors. So I have three colors, red, green, blue, and I have a button to add a new color. So when I click on the button, I'll push in a yellow, and hopefully you'll see yellow added to the list. So under here, I loop through the colors with the list color, and then I show what's the color what's the color right now, right? So when I click, you'll see one new color added at the end of the list. So what happens here? If we investigate this, what happens is that Svelte will actually loop through the list, right? So previously the list only have 3 items, now you have 4 items. So you will loop through a list and compare one by one the color and the index. Well, it does not really compare the color and the index. It compares what is being shown on the screen and what is going to show. What is showing and what is going to show, right? So right now, the first item is showing red, and we're going to show red as well, so nothing to do. And second item is showing green, and we're going to show green as well, so nothing to do. Third item is blue, and we're going to show blue as well, so nothing to do over there. And then we don't have any items left, but we still want to show one more item, which is the fourth item is yellow. So we add a new item at the end of the list, show it, add it as a list item, and the content is yellow, and there you have it. Right, so if I come over here and I inspect elements, we're gonna see closer, a little bit closer, and what is happening, right? So I'm gonna reset this. I'm gonna inspect again. So before we inspect, I am going to use the developer tools to save the reference of the list item so that you can know that whether what I say is true, right? What I say is that you will compare the first 3 items, and then the fourth item is newly inserted, right? So I compare a reference and see whether do I remove any of the elements or are they the same reference. So I'm gonna save it over here. So I'm gonna say A. Okay, I'm gonna name it better, right? So the first item equals to the current element I'm selecting. So this one, the red, and I highlight the second one, and the second item is 0, and third item. So first, second, and third. Okay, and now I'm going to click the button to insert yellow into the list. Okay, if you notice over here as well, it flashes something over here, right? I don't want to restart because I have to retype everything, but rewind, pause this and rewind, you can see that the fourth item flashes and nothing flashes on the first 3 items because you don't have anything changed. Right, so now interesting thing happens, right? We want to compare the item. So if I come over here, this is this current item, and we're going to compare first item. Is the reference equals to the first one? Yes, it is. So we're reusing the same element. Okay, that's good. Let's check the second item, and then we highlight the second, right? And whoops, right? It is true, right? So the second item is equals to the second element over here. Let's highlight the third element and let's type third item. It is true as well, so that's great. And the fourth one, no one is we don't have that fourth item yet, so it's a new item, so we can't compare with any of the elements, right? That's great. So what happens if right now, instead of pushing yellow at the end of the list, I'm going to insert yellow at, say, the second position. So I'm going to use splice instead, 0. So the index, I'm going to insert it in the second index, remove nothing, and then insert yellow, right? So if I, splice. So I click, you will see yellow inserted at the second position. Well, it's third in second index, so it's a third item, right? Okay, so let's come over here, and before we do that, let's restart again. Before we do that, we're gonna keep all the reference of the elements, and let's guess what's gonna happen right now. Right, so before we do that, I'm gonna say first item. Oops, highlight the second item. And then highlight the third item. Right, so first, second, third. You can see it's also hover. When I hover, it's also highlighted on the left on the REPL over here. Right, so as I click, what happens? Right, so this is what I'm going to explain what happens, and we're going to see whether it matches what I explained. Right, so I have red, green, blue, 3 elements, and right now I'm going to render 4 items. Right. And I'm going to insert yellow at the third position. So you're going to have red, green, yellow, blue. So I compare the first element and the first thing I'm going to render. Right, first thing I'm going to show. It's red and red. Okay, I'm not going to do anything. Then I'm going to see next thing. Right, the next thing I have on the screen is the green. And what I'm going to show is green as well. So nothing's changed. Okay, that's good. Third thing that I have on the screen is blue. But what I'm going to show is yellow. So instead of inserting yellow, I'm gonna change the blue color to yellow, right? Blue to yellow, because that's the third item I'm gonna show. And then fourth item, I don't have anything. I don't have fourth item element on the screen. So I create one new element called blue, and then I insert it on the screen, right? So that's what happened, right? Of course, in your mind, when I do this, you're gonna say like, shouldn't the better way, or what I want is more like keep these 3 elements and insert yellow, a new element as yellow in the third position, rather than, you know, change the blue to yellow and then insert 1 at the last? Shouldn't that be the way? Well, it's not really. And trust me, what I say is what's actually happening, and I'm gonna show you, I'm gonna prove it to you right now. So click on the buttons, and you'll see yellow on the screen now. And again, if you haven't noticed over here on the right, you can backward a bit, and you will notice that both of these elements flashes. Right, flashes means that something has changed. Right, the Chrome developer tools will flash on elements when it's changed. So I'm gonna come over here and do the element reference comparison. Right, so I come over here and say, is the first item equals to the current element? Well, it's true, yes. And the second element is the green color one. And I'm going to come over here and compare. Is the second item equals to the current? Yes, it is. And I'm going to highlight on the third one and say, is the third element equals to this? It is true again, right? But previously, remember, third item shows the color blue, but now it's showing color yellow. So it's reusing the same elements, but then change the text. And for the blue itself, we recreate a new one. This one is not equal to anything else. So it happens as what I said, right? It will compare one by one, and if it's different, you will update it. And if you have more items at the bottom, you will add it in, right? So in general, whenever the length of the array changes, whenever the array changes in general, what happens is that Svelte will go through the list one by one and compare what is on the screen and what is going to show. Even if you rearrange the things, it will still go one by one in order and update the text or the content according to what is going to show, right? It does not know it does not have no idea whatsoever about how you rearrange the item, right? You just go one by one, compare and update, and at the end of the list, if you have more items, then they will be created and inserted into the DOM. Or if you have less items, then the extra items will be removed, right? That is what happened. So again, to prove this, to show you this is what actually happens, I have another component over here. This way, I can show you that the component will actually tells you that when it's being mounted, and it will console out the color of the element that is provided to this component itself. Alright, so I can come over here, import this component, I'm going to show this component instead. I'm going to pass color. So on mounts, you see that I will mount red, green, and blue, right? You can see red, green, blue. Okay, and I have another variable that's called initial color, which will be computed, will be stored the value of color at the initialization, right? During initialization, you will store this, and it's not a reactive variable. So anytime when you change color, this will be stuck at the initial color you pass into this component. And as now what I'm going to do is I'm going to insert yellow in the third item. As soon as I click that, you see that it looks blue, right? It inserts a new item inserted is actually a blue color instead of yellow. Although we insert yellow in the middle, it does not matter. It will only check like what we have and what we're going to render. We have the extra item, and that extra item is the fourth item, which is blue color. So as you can see here, it logs out blue instead. And then one thing you can see here is that the third item, although the color right now is yellow, but the initial color is blue, right? This tells you that previously this is blue and we change the color property to yellow, right? To show on the screen. But this is purposely designed in such a way that you still show you that what was the initial color, right? So Svelte will go through the list, updates every element in order, and then anything that is extra, it will be inserted, or anything less, then it will be extraneous elements will be removed, right? Svelte has no idea whether you insert something in between or rearrange the order. Rearrange my hair as well. So, is there a way to let Svelte know that you want to rearrange the item? Right? I've said so many things so that you know like how it works, and so that you can know that you make a conscious choice to know that, okay, I know Svelte, you have no idea that I rearrange, but can I tell you that can I tell you that a way so that you know that when I reorder something, you know when I reorder it? Well, can you? Well, that's the point of this video. We're gonna do a key each block, and a key, you can think of it like an identifier for the element, because anything over here can be as your item item of your array, right? So Svelte has no way to know that whether you rearrange or you just modify one property of it, right? If it's a string, yeah, sort of, you can compare the string, but if it's an object, how can I know whether do I use like object reference, or like how can I know, right? So you can provide a way to tell Svelte that, okay, this property or this value is the key. You use this key to compare. If right now, if I show a list of elements, each of them has its own key, and anytime when and then when I update something, you compare. I will also use for each of the things that I'm going to show will also have a key, and you compare the key first. So if the key shows if the key appears previously, but now it's in a different order because it's showing earlier on, or you rearrange it somehow, then you know that this element should be shuffled onto the top rather than, compare one by one and update element one by one, right? So how you write that key? Well, you come over here, each array as item, and then you can add index as well. Whether you have index or not is up to you. But to provide a key, what you do is you use a bracket. And inside a bracket, you can write any JavaScript expressions. Again, any JavaScript expressions. You can call a function, you can have plus, you can like adding up multiple elements, or you can do whatever you want. Any JavaScript expressions. But of course, make sure that it evaluates to something that you can store in a map, right? Of course, you can store anything in a map, but I would suggest that, put in some sort of strings or numbers or that kind of thing. Something simple, right? Don't put because Svelte will have to hold it in reference in a map, and you wouldn't want to throw everything in there. So over here, Of course, whether is there a performance penalty, you would have to test it out to know for sure. But in most cases, you just need something like a string, right? In this case, we have colors, and we can use the color itself as a key, right? So that I know that, okay, red, green, blue, right? If I insert yellow in between, yellow should have a key of yellow as well. So you know that blue, the key blue is still there, right? It's just like shuffle to the bottom so that we know that, okay, we compare the key first, right? All of the item is still there, but then yellow is a new one, so we insert yellow in, and then we push the blue down at the end, right? So that is what will happen. So I can use color as a key. So to show you, I'm gonna say key is color. I'm gonna comment this for temporarily. So you have red, green, blue, and the key is the red, green, and blue. You can have anything as a key. In this example, I'm just gonna use the color itself as a key. Okay. So I come over here. Now do the same thing that we have done earlier on. We're gonna skip the reference and then we compare the reference, right? So in this time round, we're gonna say what we're gonna happen is that you will compare the key first, right? So right now you're gonna show red, green, blue. You have 3 keys. And when you insert yellow, you have red, green, blue, yellow. You have 4 keys, right? So you will find every time when you render, you see red, the key is red, find where is it, and then if it appears at the bottom, you will move it to the top, right? And then I'm gonna use green, find through the list where is the key, which element has a key green, insert it there, right? Yellow, do we have anything that is yellow? No, then we create one. And then blue, do we have any elements that is blue? Yes, we will insert that over here, right? So things will be reshuffled. So if I come over here and I keep the reference, so I'm gonna keep the reference first. So I'm gonna say first item equals this, right? First item equals this. Second item equals, highlight this, this. And third item equals to this. Right, it's first, second, third, and now when I insert yellow, if you backwards a bit, you will see that only the third item flashes, right? The fourth item will be shift downwards. So let's compare whether the reference of each of the elements has changed, right? So if I come over here and say first item equals to the current element, yes, it's true, right? We reuse this. Second element, it is true as well. And let's look at the third item. Third element. It is false, right? This is a newly added, newly inserted element, newly created and newly inserted. So yellow is something new. And then, but you compare the fourth one and you see it's true, right? We reuse this, right? We reuse blue. So blue is shifted downwards and we insert yellow inside, right? So if I come over here and use the component instead, you see that, okay, initially we are say red, green, and blue, right? We are mounting red, green, and blue. And when I click to add a new yellow, insert a yellow in between in the third item, you see that a new component is created, which is color yellow. And now as you can see also, the initial color of that is also yellow, right? This is a newly created component inserted into the list, right? So if you instead come over here, if we do something like a reverse colors.reverse, you see that when I click, again it's also yellow is created, and even though like we reshuffle, we're gonna reuse all the elements will be just reshuffle, and it knows it use the key to look up from the previous rendered version to find out where the element is and then insert it in order of what you're gonna show next. Right, so why is this important? Well, this is important in a few ways, in 2 ways. First is that you reuse the element reference in ways that you are expecting it to, right? You don't update the elements one by one to change this, right? So if you have a huge list which you want to insert something in between, right? So if you don't have a keyed edge map, what will happen is that you compare, and from that item onwards, you always have off by one error where all the elements have to update to a new value because something has inserted in below, and you shift down. So you compare the for example, you insert at the second position, then the third item is equals the old second item is equals to the third item, and third is equal to fourth, fourth equals to fifth. It always have to update itself because the value is different, right? So having keyed allows you to insert anything in between, but still keep a reference, keep using the same reference instead of updating. Of course, there's penalty in terms of space. You actually have to keep a reference using a key. You have a map to keep the key with reference to the elements so that you can reuse that elements, right? So that is like a you're trading a space with like time efficiency, right? Of course, however, if you are using components where it itself has some life cycle methods where when the components created, like in the example we've shown, you use on mounts, and when you update it, you use like before updates and things like that. Well, and probably you want to make some API calls or make something when the properties has changed. Well, in a list, in a context where you use it in a list, most likely you want to if the item is not changed, you most likely will want to use the same item. Is like if something is inserted in front or reshuffled, you most likely want to reuse the same data for the component rather than update the data for each of them so that it matches the new order, right? In that case, you want to use a keyed edge block. And lastly, there's also one reason you want to use a keyed edge block is when you add transitions or animations when you reshuffle the items. This is something we're going to learn later on how to add transitions or animations when you add something to the list. But here is how it will work with them, right? You need to know, you need to keep the reference of where it was, and you have to move it up instead of just updating the value, right? If you update the value, then there's nothing to transition or animate about, right? So you need to keep the reference. You need to know that, okay, I'm going to reuse the same element, but previously it's at the fourth position. Now you have to shift to the first position. And while you move it over, you need to add some animation. That's how animation or transition will work with a keyed edge block. So there you have it, a keyed edge block. And I hope that I explained it clearly with you. And if you're not clear enough, watch it again, watch this video again, and play around with the reference or life cycle so that you can clearly see the effect of whether you're updating an element or reusing an element or create a new element, right? Especially when you insert something, should it be created or should it be updated on the existing elements, right? So comments down below if you have any questions, if you are unclear of. And give me a thumbs up if you like this video, right? Smash the like button. And as always, subscribe to my channel so you get notified when the next one is out. So see ya. Bye bye.